All right, so you are being recorded right now, just as a heads up again. I'm Samantha. I am a co-founder and catalyst within Re3D. I had a delayed flight, so I'm here from my house today, but I'm joined by some of our teammates from the factory in Austin, Texas, and in our presence in Houston, Texas. And today is kind of a special opportunity for us as the user group. I know we have highlighted ourselves a couple times, but we've had a few by name request presentations, specifically with Michael Pujols Vazquez, who's down in Puerto Rico in Bayamon, and is just our industrial designer and a huge asset to our team. Mike actually went to the Universidad de Turabo and has a minor in entrepreneurship, industrial and product design. He also has a bachelor's degree. And he's a true maker at heart. He's been a studio assistant, a junior designer. He had a welding and plasma venture, as well as starting his own startup when we first got to meet him through Parallel 18, Parallel 18, called En Espacio. Just has a real eye for clean and unique visuals, but also, a maker at heart. So he seemed like the perfect fit when we launched our first GigaLab through the Puerto Rican Science and Research Trust, and a match with our NSF award you'll hear about here shortly. We needed someone to staff it full time as part of that contract, and Mike was the perfect fit. Also as a maker, you'll learn more, but the GigaLab is located at Engine 4, which is an amazing IoT lab. So it's been fun to grow with Mike and see his engagement with the technical and making and innovative community and PR. And he's really informed what the GigaLab became and will become going forward, and has led a lot of the retrofits where now we contract out some of that work. Mike's put in a lot of labor of love, personalizing the container and giving feedback that led to the NSF Convergence project we highlighted and others. So with that in mind, I'm going to turn it over to Mike. I'm so honored to introduce him to y'all. I hope that you will get to visit the GigaLab if you're ever in Puerto Rico. He gives tours daily, and to see where the conversation goes. All right, Mike, take it away.
Awesome. Thank you, Samantha, for the wonderful introduction. So this is gonna be we're gonna change a lot of context in this presentation. There's a lot of that goes all over the place. That's why it's kind of called cross-pollination or cross-pollinating design for FGF, and and how different communities, materials, people, ideas, missions, and all of that influences how FGF moves forward. Um, and that's why each lab informs the next. So without further ado, I wanted to start this hold on this presentation with our ethos. We are a team that works hard with a community to produce quality lifetime solutions to empower anyone, anywhere, anytime in an open way. And I hope that this presentation is a testament to this ethos. This is a great team of people that I get to work with at a daily basis. They inform every step of the way of this process, and I'm very grateful for each and every one of them. I've learned so much from this team, and um, every little detail of design work is thanks to them. So let's start with the GigaLab. GigaLab is funded by NSF from SBIR with a matching fund from Puerto Rico Science and Trust Fund, and with active partnership with Municipio Bayamón and Engine 4 Foundation. The Engine 4 Foundation is a lot of things. It started as a co-working space where a lot of entrepreneurs, startups, and communities ranging from programmers, engineers to just like marketing and AI now and 3D printing, started creating this ecosystem or community to empower each other and look for ways to grow their businesses. So it started as a co-working space and then later grew onto a research lab with its own IoT lab powered by T-Mobile, Intel, Microsoft, and a bunch of other huge companies. Um, so it was a no-brainer to have Engine 4 as a partner for the first for the first Giga Lab. And well, the first Giga Lab arrived around March 1st, I believe, in 2023. It was my first work day. It was a very interesting turn of events. It was a very chaotic in terms of like logistics to get it here, and very grateful to actually be part of that first arrival for the Giga Lab. Um, a lot of work. This work is like tremendous from a lot of levels, and I'm very grateful for everybody that was involved with it. So on creating the Gigabot was a really interesting experience. This was my first time to actually unbox a huge printer like this. So a lot of people just walked by and looked at me like strangely, like, what is that? And asked a bunch of questions. A lot of them want to help me as well. But then, the Giga Lab just arrived with the two bots and a granulator, which is the basic tools to start it. But we need to outfit it. So we started with electrical. I sanded the floor. I sealed the floor. Um, and then went on to like, cutting the panels, putting on the ceiling panels, and Samantha helped me out with coding and adding the decal for what now looks kind of presentable. And Yeah, it's a very cozy working space for creating different designs. But before, creating designs and testing materials, we kind of start with a very basic cylinder test. This is how I started for a couple of hours, just like trying to tune different temperatures um, for the materials. I started off with pelletized RPTG from recycled water bottles. And then from there, I just quickly started designing a bunch of things. First, tried to like design a lamp to the core engine 4 and the interior. This was a lot more challenging than I thought at first. It's a very thin wall design. It only has one wall. I printed it with 1.8 millimeter nozzle with a hopefully dried RPTG at that time. Um, but Yeah, it was a lot of learning experience with this one as well because I had to design the tool path so that it won't like bridge with each other, and maintain the walls as thin as possible so the light could come out. Um, so then after this, I tried to tackle a challenge that I had in my mind, which was like, can we 3D print non-planar on this on the Gigabot X? And the answer is yes. And also it is more complicated than I thought it would be. It's also a lot of this process is more like um, not just like speed of the printer, but it's also extrusion speed or around the corners. So as it goes down, it starts to like create pressure on material buildup and on the nozzle. And as it goes back up, it starts to like over extrude because of that buildup on the back side of this print. It's not really visible there, but that is a issue that would change depending on the geometry of the part. And so I wanted to try this out and see if I could build this is like a small test, but I wanted to build a chair that would have this sort of geometry, or that it would just start building non-planar layers so that each layer can help the support of the chair properly. So each layer would be continuous or the same length in theory, um, instead of it being like shorter lengths as it goes and builds itself. It was a lot more challenging, so I ended up going the normal planar level or layer by layer of printing. Um, and I printed a bunch of chairs. A couple of them did not print completely because electricity went out a couple of times. And 68 hours of printing and 30 pounds of material. Yeah, there's a lot of time in between each share. But this one got to, got decent, like it got to finish. I got to finish this one, and I got to like a couple of hours sitting on it before I asked a friend if he could, test it for me. And he's a little heftier. And then I asked him to sit on it and help me figure out how to break it because that's part of the process. Um, and then this is like this is the chair itself, and here I'm demonstrating how it could actually hold weight, at least my weight. And I got to like stand on it and sit on it for a bit. I like the backrest; it actually helps out a little bit. But then, I asked for my friend to help me out, test it out, and he instantly broke it. He told me he only used like about 10% of his power. The only thing he did was basically just put his foot on the one of the corners of the chair. I should have done a finite element analysis on that to see if that corner would have taken that much uh, force. Um, but lesson learned. Before printing, try doing a finite element analysis on the design before printing. And then after this, I wanted to try out a different design and learn a little bit of like how like what to what extent the printer can bridge to like a certain height of the design. And I came up with this design where each of the legs kind of like converge at the top and create like a little bridge so that becomes like the little footrest area for the stool. It works pretty well. I got away with it and by like at least halving the amount of material from the other chair. Instead of 30 pounds, it's 15 pounds. It's a pretty good progress. Um, and I got Barbara from Green Gate to come over and Richard to look at how we're printing stuff. And she got to sit on it, which was really cool to see. Um, and also we use the share like to demonstrate like to Maya West University of Maya West engineering students how like we can recycle materials and they pass it around just to feel how heavy it was compared to another FDM printed chair that we have around here. And then jumping again to another project, basically, I had an idea since I think before I started working with VGD of like trying to print on top of textiles a kite frame and seeing how that could potentially be a quick or some sort of like idea for like making drones or that sort of thing. But using recycled materials in this case would be an interesting add-on to that project. It did sort of work until like the wind started to pick up really, really like heavily, and then it went up, and then as it kept getting up, it like snapped in half and fell, and I almost hit somebody. Um, and that person wasn't really happy with what they were looking at. Um, and then jumping again, this is a really cool project that started with the GigaLab, more of a collaboration with Emily. She is she had a rotation plasty surgery because she had osteosarcoma on her leg. So she got amputated, and rotation plasty is a very interesting surgery where they basically cut your leg and then they cut your foot and rotate your foot and basically weld your foot onto your where your knee is at. So the ankle works as the articulation that as if it were as if it was your knee. So osteosarcoma, revisionplasty amputees have very unique geometry prosthetic. And since she was like very young, having the surgery, her dad wanted to like design a cover for this prosthetic to mimic the shape of a leg, so it could help her develop a relationship with that process. And so we started early on developing this prosthetic leg cover using recycled materials and um, using the GBX for it. This is again another style of toolpath. It's meant for the toolpath is meant for like it doesn't cross its own toolpath again, so it just keeps looping back and forth. It doesn't do the middle section, this middle section here. It doesn't jump from here to here. It helped out a lot with vibrations, because this is a very small base for this type of geometry printed on the printer. It's about still about 8 hours to print this sort of thing, because of how thin everything is. But it worked out great for us to like visualize the how we can take this further. In terms of aesthetic, we kind of wanted something a little bit more sleek and also durable, because she runs a lot. And we started noticing with the first couple of covers is that she would bang against everything and basically break the covers almost instantly. So covers weren't doing that much of a great job. But we started prototyping with TPU and we got great results. We started printing FDM TPU, and we also post-processed that TPU with automotive paint, and got a design for her that she feels really good with. So good, in fact, that she travels from Puerto Rico to Boston for like every couple months to change out her prosthetic leg. But also her friends wanted a similar cover, so we got to make her friends the cover for them as well. This is a very this is one of my favorite projects because it involves so many things from 3D scanning to 3D printing, and also like that post-processing part of sending over the TPU prosthetic leg cover and getting it painted and seeing how they feel with the cover is very gratifying in that sense. And so this is a very random project. The mayor of Bayamon came over and dropped this huge drone on a table and told us, "Hey, I need you guys to design a part that would hold a care package and drop it if there's like an earthquake happening. And there will be a earthquake simulation in a couple of weeks, and we kind of need this for that demonstration." And this was a whole thing. They demolition the school, and hired a bunch of actors to play as if that whole earthquake was happening. And this is all just a demonstration of like how the disaster response could aid in an earthquake. So they also had ambulances come by and police and a bunch of stuff, and it was a whole thing. I have a link to the file, but also in that file link, you can find a Telemundo report on it and get a bit of more context on it. It's on the QR code for the Thingiverse file on the corner, the right corner. But this design started as an FGF print, and later on evolved into a more refined design on FDM. But thanks to the FGF, I got to make it a little bit faster. So this motorized dropper that the drone has, it can only hold O-rings at that time. So that's why it has in this case, it needed to have a bigger sort of O-ring to hold the care package, because we were using each individual little finger um that the dropper has to hold a bigger care package, and it could carry at least a pack of water bottles over if there's a another type of disaster. And then jumping to another really interesting project or invitation to an event. Um, Richard Lee got invited to Haystack Mountain School of Craft for their annually Haystack Labs event, where they invite other makers, creators, and industry professionals to um, I guess it's like a sort of a hackathon, but also it's a retreat, and you get to learn and play around with tools and stuff. And we all got to basically make stuff for at least 6 days, and it was really fun. Um, so a lot of prints, like the GBX got to print for at least the whole weekend. Um, and we got to use the wood fill PLA from University of Maine, which so far is my favorite material that I printed on GBX. This material is super easy to print with, and we got to do a lot of really interesting designs I've never gotten to experiment with, and it's all thanks to Shelby Doyle. She wanted to push a little bit of the some ideas that we can do on GBX that sort of come from clay printing in that case. There's like these intentional overhangs that could have like these perforations for design. It could this could be used for lamps and all sorts of things, but you need to get that viscosity of the material kind of right for it to kind of work. Um, and the PLA is a pretty easy material to work with, so. And this is another one. This is a bigger sort of weave basket. It kind of looks like ramen. It's not. Um, it's this took about all night to print, about 8 hours. Um, yeah, it was a really interesting experiment. Another experiment we did was a 3D scan by Jenna Fizzle. She used her um, Apple Vision Pro to 3D scan a tree outside and then got to scale the tree 3D model to the size she wanted to 3D print, basically export the file, and we printed it using wood-filled PLA. So a tree made out of a tree and 3D scan, that sort of thing. Kind of a weird inception there. Um, but a really cool experiment. Again, one of those things that happen when you gather a bunch of interesting people together. Um, and as it was basically a hackathon, there was a lot of coffee mugs around the studio area. And then walking from the studio area to the kitchen where we had to do where we had to like take those mugs to every day, but they started accumulating over time. And so I designed a coffee mug for that specific problem because we were too lazy to bring the coffee mugs from the beginning. So at the end, we have too many coffee mugs. Um, and the kitchen staff loved it. We made a couple of them for them because it appears that that sort of problem happened before with other labs and other workshops. So I got to leave a little bit of a design there as well. Um, so now jumping from Haystack Mountain over to New Mexico at Cannon Air Force Base. This is a DoD SBIR Phase 2, another GigaLab project. It's a really cool GigaLab because this one is powered, at least the right container is powered with a wind turbine and batteries. And then the left one is powered by a generator because the granulator needs a little bit more juice. Um, but this was a really cool demonstration where we got there, we set up the wind turbine and got the batteries running and the printer working and got to teach or train airmen how to use Simplified 3D to 3D print their models. Um, and a lot of them wanted to print things that were kind of a little difficult to print on GBX in the sense of like the tolerances for these parts are designed for smaller nozzle sizes. So the GBX starts from 0.8 millimeters to about 3 millimeters that we've tested. And yeah, they wanted to try these out. We printed them out. The features were too small, and also in this case the PTG was not dry as well. But a lot of learnings from this as well. At least for them is to like to show them that you also need to design for the machine or the constraints of the machine, not just take a model and then throw it at the printer and see what happens, sort of thing. Um, and then from that project, we took drones from we took material from discarded drones and then 3D printed drone frames. Um, this is also a very interesting process where we got to show like if you get the right geometry and the right tolerances, you can actually get a good result. And then got to fly the team got to fly a 3D printed drone from this, which is really interesting. Each drone frame, if done, a production of drone frames can be done in under 30 minutes, which is pretty fairly quickly. You can have different iterations and churn out designs pretty quickly with with this nozzle size. And also we got to design a cable management little strap. A suggestion from a staff sergeant that works with the cybersecurity department. She wanted to like design this little strap thing, and we got to do it on site as well, which was really cool. Um, and then jumping from New Mexico over to the Pacific, we got to demonstrate thanks to American Makes, we got a booth at PostFX, which is a conference where a lot of DoD and uh, companies get to show off their technology that they're developing. We got to specific Pacific conference, we got to show off the GBXS printing our LDPE foam that will be eventually used for packaging foam for the International Space Station. It's really cool to show off a lot of good ideas. Some people suggested maybe doing a system, this sort of configuration for submarines and that sort of thing. Which was a really good feedback for this. But Patrick can attest to how this project is going. He's if you haven't seen Patrick's presentation, you probably should go watch it. It's really cool. He does a lot of really cool NASA stuff. And we also at the end of the week we got to show a lot of the demo parts we make for DoD at PostFX demo, which was like a 3 hour demo. Got to print out drone frames. A lot of the learnings that we took from Cannon Air Force Base, we got to showcase it here. There was a few drone frames that we got to print out every like 15 minutes or so as we were talking and demonstrating from granulation to actually printing on site, which was really cool. And then jumping from Hawaii over to the Austin Habitat for Humanity recreated GigaLab. This is a really cool project that starts from NSF Convergence Phase 2 grant. So in the interior of this GigaLab, you get to see how maybe building out the GigaLab from scratch isn't the best starting point. It's a really good thing to like have a already built out GigaLab, and you can have it running parts. The team at the Recreated are doing awesome things with the GBX. They're actually making things and selling them at the Restore, which is amazing. It's a really good demonstration of like how you can take waste, donated waste to actually sell them at a local shop, and um, that's super cool. And um, so relating to like Austin and design and that sort of thing, I got approached to maybe, like help out a little bit and design something that could be related to Austin. And I got a list of things that I have to make for the recreated team. But I started off with something that could be maybe potentially sold um, year round, maybe because of the interesting phenomenon that happens at Austin, which is the river bats that migrate. About 100,000 river bats migrate around the spring and the summertime um, in Austin, which is a interesting thing. That doesn't happen here in Puerto Rico. So it's a really cool thing to see at Congress Avenue Bridge. And we started developing a interesting looking bat, a 3D printable bat. Um, and I got to learn a lot from this as well in terms of material. I got some uh, recycled polypropylene from from local industrial waste, and tried to 3D print my own design on the GBX and had no success. And basically, um, started asking Chris if like what am I doing wrong, and maybe like if he can help me like tune the design a bit or and stuff. And basically he gave me a lot of really good guiding principles. RPP doesn't like sharp corners. This design had a lot of sharp corners in the wings. So it started like to drag material from the corners, and basically would come loose from the print bed even if I put adhesive on it. And um, so I edited the design a little bit. Still has a little bit of sharp corners on it, but even less so that the design could sit a little better on the build plate. It could also be material. There could be a material thing happening there where maybe the RPP that I have is the thermal cycles are a bit different than the other ones, but it's coming out really good on Recreated. Um, so the Recreated team has these materials so far. They have tote containers, and these little containers from that are made from RLDP. And Chris did an amazing job with like 3D printing these things. Um, and it's a really cool process to see how maybe something that doesn't quite that I don't really quite have it working here, but also like sending off that design and getting feedback and seeing how that can work across the pond, if you will, remotely is really cool to see. So with that, um, so basically with that, I I wanted to emphasize the how this whole process wouldn't like happen. The design, like all these learnings from design wouldn't happen without our ethos and how we take this like, pretty seriously in terms of like, um, and yeah, there's a lot of work that happens in a retreat to get these things right. Um, so I hope that, kind of shows off how all these little network of labs collaborate, and we get to learn a lot from it. Thank you.
Mike, thank you so much for that wonderful presentation. It's so cool to see how the projects have intersected and you've influenced their development. Does anyone have any questions for Mike? with that in mind, then we'll go ahead and turn the recording off in case someone wants to ask a question that won't be shared on YouTube. As always, know that if you're interested in presenting, you do not have to have a Gigabot or X2 or a Gigalab. Our hope is that we can build connections across all of the FGF community. And I think next month, we might be having a presenter that's a peer in our ecosystem. So we'll be sharing that on social media soon. But we'll go ahead and turn the recording off. Mm-hmm.